Still in Module 3, we're going to talk about protocol suites here, a little bit about protocols and standards. So let's go ahead and get into these. Protocol is just a set of rules that we're going to follow in order to ensure that things are going to work the way that they're supposed to work. We have protocols for all kinds of different things, and everyone's familiar with that. And we're just going to do a couple of things here to talk about data communications. And in this case, it shows the evolution of protocol suites and brings up a couple of things that we should talk about. So one of them talks about the idea of the Internet Protocol Suite, or TCP/IP. This is what we're going to study for the next 4 classes or so and beyond. And it is the underlining or underpinning technology that allows the internet to work, and it is a pure technology that is going to, if you set it up correctly, it will work. It will work for you. The second bullet point they get to on this slide, they talk about the idea of the OSI model, the Open Systems Interconnection Protocol, and what this is just an organizational group that said, things are a little bit weird. And a lot of people don't understand them straight away. So what we're going to do is we're going to develop a standardization model, and that's going to allow us to break down all of the steps of communication. And the OSI model is actually 7 steps, and it ends up showing up at the very end, one of the last slides in the chapter. But in this case, we're just talking about the idea that there is this OSI model. And we have standards that we're going to work within. And then down below that, there's 2 other protocols that you can use for data communication. You're like, you know what? I'm a rebel. I don't want to use the internet because TCP/IP is whatever. You don't like it. It was, who knows? You could use a different protocol. You don't have to use TCP/IP. You could use something called AppleTalk. I can't imagine what manufacturer came up with that product. Maybe Apple, I'm not sure. And then before TCP/IP had the world by storm, some of us, and this is really when I got involved in networking, there was a product called Novell Network, and I had a certification, and it was called a CNA, and it wasn't Certified Nursing Assistant or whatever what CNA normally stands for. It's like a nursing credential. It stands for Certified Novell Administrator, and that meant that you could network computers in the early 1990s because TCP/IP was working with Unix, and most businesses were using Windows 3.1 or Windows for Workgroups that either barely had the ability to communicate or didn't have the ability to communicate natively. They didn't have a networking component within their operating system. So they were relying upon Novell to run as an application, and that would then become the networking component of the OS, and you use Novell Network. And everybody used Novell Network until everybody started using TCP/IP. So Novell used a protocol called IPX/SPX, and we used to just call it IPX because that was simpler and easier. It was like TCP/IP. It was a 2-headed system that worked with token ring and Ethernet, just like TCP/IP. It was actually an easier system to utilize. The addressing was simpler, but the internet was based in TCP/IP. So really TCP/IP kind of won that battle based on the fact that if you wanted to get on the internet, you had to use TCP/IP, and Novell wasn't going to get you there. So Novell went by the wayside, and it's no longer a protocol that people are using, but you get the basic idea. And it's probably not always going to be TCP/IP. It could be something else in the future. We haven't seen anything else yet, but that is something that is possible. This slide here does a nice job of showing a model, what's called the TCP/IP model, and it's showing a bunch of different acronyms in boxes. And really, the way you can kind of look at this from the stuff that we studied before, if you look down here at network access is really the physical layer and what's also known as the data link layer. and that's where Ethernet's going to reside. This is where our MAC addresses are going to be displayed to each other. Information we need to pass to each other about finding MAC addresses, the things we would do with a wireless LAN, all that stuff is going to be posted down here in this particular box. And then you kind of move up the chain towards the operating system. So the physical address or the MAC address will be posted here. Our global address would be posted in this area. And then, like I said, it shows the different protocols that are available there. IPv4, IPv6, global addresses. Transport layer, TCP and UDP. Two formats, remember, reliable and unreliable. We went through that in the previous video. And then at the top are all the applications that you can use that will create information for another device, and also will receive information from another device and then generate it into something that's usable. So it just mentions HTTP there, which is just web traffic, and DNS, which is a helper protocol, and DHCP, which is another helper protocol to pass addresses around. We don't need to talk about that today. And then FTP, which is a file transport protocol, which is a method to transport files back and forth from one device to another. So that's all they're getting into here as far as these protocols go, and what you would need to learn on that. This is another really nice slide that shows the TCP IP Protocol Suite. This is what we're going to be working within. And one of the things you just want to kind of get yourself familiar with is the different acronyms and the different layers they're associated with. So once again, the network access layer, that's where our switches are going to interact with our MAC addresses. And we're going to use something called ARP here. It's also known as Ethernet. It's an Ethernet header. And we'll get into some packet analysis on that. Internet layer, global addresses, IPv4. We've got to be familiar with that. IPv6, longer addresses. Transport layer, TCP or UDP, that's it. And then really everything else, the other kind of services that you're going to want to work within are going to be acronyms. They're going to be up at the application layer. And here's the thing. All these protocols that you see here are protocols that are part of the TCP IP suite. What that means is this. It means that if you've got a computer and it runs TCP IP, then it will be able to understand code that you send it about DNS. It'll be able to understand code you send it to it about DHCP. It'll understand all the protocols of all of the underpinning applications that we see across the top here. So SMTP, that's the global method that we're going to use to send email messages. IMAP, a global method that's used to receive email messages. Why do we have to have a global method? Because if we don't have a global method, then we don't have a global system. So everyone's got to participate in the exact same way and follow the same protocol and the same rules in order for it to work. I mean, otherwise, you're just going to have to, figure everything out on your own, and that's just not a very efficient method for a global data communications process. So that's a little bit about this slide here. Moving on, it's kind of the same thing as we go. This just reminds us that binary code is the underlying technology behind all of this, and we'll get into that in a future slide also. And then the next couple of things that I wanted to get into is, and very quickly, and we're not going to spend a ton of time on standards, but they do like to ask questions about the standards, only because I think that they're really easy questions to ask. But on this slide, you do see some of the logos for some of the different standards that are out there. And standards are great. So if you look at this slide, there's a couple I can point out here. IANA for one, and ICANN. The only way the internet works is that every device that's on the internet has to have a unique value to identify where it is within the system. And if someone's not keeping track of those addresses, then there will become overlaps of those addresses. And overlaps on addresses are very, very bad. It would be kind of like you having an overlap of your home address. Hey, I live at 123 Main Street in Glen Ellen, Illinois. Fantastic. Hey, I also live at 123 Main Street, Glen Ellen, Illinois. But we don't live together. But we have the same exact address. That's a collision, and that's a bad thing. That is going to break down the system. So you have to have unique values identifying locations, and those are then parsed out, and it scales out through routers and routers make forwarding decisions to find those values, those network addresses. And IANA and ICANN are the two organizations that make sure that there are no overlap on, number one, IP addresses. You can't have duplicate IP addresses in the system. And two, you can't have duplicate names. You can't say, hey, I'm cod.edu. I'm running my own college. I'm going to call my domain name cod.edu. It's not College of DuPage. It's just for fish or something. It's cod.edu. It doesn't matter. The thing is, I can't. If cod.edu has already been taken, I can't use it. I can't duplicate that domain name because that's got to be a unique place on the internet, right? That's all they're getting to here. So having a standard for numbers and names allows the system to be global. The other thing that they define here, or one of the other organizations that are listed here, is the IEEE. And IEEE is a consortium of electrical engineers that will share information and best practices so that we don't have to reinvent the wheel every time we come up with something new. So, for instance, we're all familiar, at least a little bit, with networking, and usually by this time in the class, we'd all be together and we'd go on a tour, and I'd show you pictures, or we'd physically experience walking through the basement of the BIC, and we'd look at all the wires that are running across the building, and I would say, well, this one's fiber optic, and this one's a data cable, and these ones are red because they're for the fire alarm system, and these ones are yellow because they're working with this other system, and there's all kinds of wires and techniques to post those, and the fact of the matter is, pretty much a data cable is a data cable. If it's a twisted pair cable, it doesn't matter what manufacturer you buy it from. It's going to adhere to the specifications that allow it to send the right amount of data through it. And that's because the IEEE has a standard for those data cables. There's also standards for the end jacks, the jacks that are used, and for the position of the wires that are used in twisted pair cable. But we'll get into media in the next slide. I just wanted you to be aware that these standards are there and they're available, and they're used as best practices to move the technology forward faster. And that's what they're getting into when they get into these different standards here. All right, that's enough for this particular slide. We'll move into I forgot what we're going to talk about next. Oh, OSI model next. So be ready for that one.